question of the day which is frequently asked. Like you can see that you have been asked to find the substances from which N2 is obtained upon heating. That means thermal decomposition of all these substances leads to what? You take ammonium nitrate. If it is nitrite, it would have produced N2. And you know about ammonium nitrate, that it is the major source of preparation for N2O, nitrous oxide. So A will not produce N2. If this would have been NO2, then it would have produced. Now A is not the correct answer. Now you can see ammonium dichromate. You study this in the basic properties of the dichromate or ammonia. You know that this upon strong heating gives rise to N2Cr2O3 and H2O. Alright, this is internal redox reaction. That means what? Inside -3 is changing, nitrogen is changing from -3 to 0 and chromium is changing from +6 to +3. So this is acting as a reducing agent, giving away its electron, and this is acting as the oxidizing agent internally, because you know the dichromate in acidic medium, since there are ammonium ions, is a strong oxidant. So this is possible, isn't it? So option B is correct. And you know that when you take barium azide, that is N3 minus, you know that it is smaller in size because of the nitrogen atom. It would have a stronger bond with the magnesium species but not with the barium species, because barium is large. So this upon heating gives rise to the barium and N2 gas. Lastly, Mg3N2, as I just said, this does not undergo any sort of thermal decomposition because Mg plus 2 N minus 3 sizes are approximately same, and this combination is stable. This is thermally stable compound. So T does not dissociate on heating. C gives rise to N2 because it is unstable, because nitrogen is small, barium is large, does not fit well in the lattice. So right answer for this question is option B and C. Alright, hope you are following. Let's see the next question. You can see that you are given the chlorate ion and reacting with chloride under acidic conditions. You know, very important reaction. You will be getting what? ClO2. This is the paramagnetic gas. Alright, here what's happening, that chlorine, whose oxidation state is +5, is changing to +4. That means this is reduction, and -1 to +4 is nothing but oxidation. So this is a redox reaction, isn't it? So ClO2 is the product which is obtained after the reaction. You can see it's a paramagnetic gas. How would I know that it is paramagnetic? You find out N/2, which I had been repeatedly telling you. Valence electrons plus hydrogen 0, halogens attached 0, minus charge is 0. That means whenever you get a fractional value for these substances such as ClO2, NO2, etc., you have to consider this as what? The paramagnetic. So this is the easiest way to identify the paramagnetism in the covalent compounds. This is in fact a technique. Alright, so you find N/2, and if it is a fractional value, it could be or it may be paramagnetic by nature. Now you see what's happening, that this ClO2 is reacting with ozone. You know that this is very popular reaction, gives rise to what? Cl2O6. So chlorine got further oxidized, right? You know, you can see here chlorine is +1, this is +4. So there is no point that, you know, ozone, which is a strong oxidizing agent, would reduce this chlorine. So these two options are ruled out. However, we are left with only these two options. This could have been possible if this is a very strong oxidizing agent like dichromate. But since this is good oxidizing, decent oxidizing, but not very strong like KMnO4, K2Cr2O7, the reaction stop at with +6 oxidation state. Along with that, ozone gets reduced to O2, isn't it? So the gas that is obtained, okay, reacts further to give you Cl2. Okay, O6 is the right answer. That is option C.